All right, so at this point in the lab, you should have checked out the video and you should have gotten your time values that correspond to each displacement. These time values are made up, so these are not the ones you will have. So the answers I'm going to get right now are not the answers you will get. So one thing it says to do in the lab is to create a displacement versus time graph, put the equation on the chart, interpret that equation to find the acceleration. I'm not going to go through how to do that because you should know how to do that at this point. What I am going to show you how to do is how to find velocity here. Now, we know velocity is distance over time, but we have to be careful when we do that. What we're going to do is we're going to find the slope at specific time and distance intervals. So let's talk about what exactly we're going to do. So we know that velocity is change in position over change in time, or displacement over time. All right, so here's what I'm going to do. I'm going to set the velocity here. So I'm going to actually skip this first cell here. My velocity is equal to, in parentheses, change in position. So I'm going to take the position after 0.6 seconds and the position before 0.6 seconds. Okay, that's my change in position. Divided by time after 0.6 seconds minus my time before 0.6 seconds. Some teachers like to use, like, let's say 0.2 minus 0 and 0.6 minus 0. While you could do that, it's just not as accurate, and I don't like doing it that way. This is slightly more accurate. It's definitely not perfect, but it does work for our purposes here. And hit enter. Click on it. See this little cross at the bottom right corner now? You can just double click, drag that down, or just click and drag it down. Only to here though, okay? Because this data point here, if we click on it, notice how it uses this data point here and this here. All right, if we drag it down again, it won't work. All right, so now we're gonna go, so then you have to create a velocity versus time graph. So you have to highlight this column, then only highlight the corresponding times. Now, how do you do that? How do you select two columns that are separate? Here's how you do it. Highlight one, hit Control or Command, whatever you're using, and highlight the other. All right. Insert, chart, and there we have our velocity versus time graph. Now you're going to fit that with a trend line. Is it linear? Is it curved? I don't know. Equation of the line. Think about how you would use that information to determine the acceleration. So not only can you use your displacement versus time graph to find the acceleration, you can use your velocity versus time graph to find the acceleration. Now, let's erase this for now, just so it's not in the way, although you could leave it there. Now, to find the acceleration, there's a few different ways you could do it. We could do it by doing the change in velocity over change in time, but our velocities were already kind of estimated, so let's think of a different way we could do it. Now, I'm going to type off to the side here. Remember the equation d equals v initial times time plus 1/2 times a times t squared? Right, well, if we're starting from rest, we know that the initial velocity is 0, so that first term goes away. So we're just left with d equals 0.5 times a times t squared. Right, now the next thing we have to do is we have to isolate a. We have to solve for a. So I guess the first thing, probably the easiest thing to do is multiply both sides by 2 to get rid of that 1/2. So let's do 2 times d equals a times t squared. We still got to get a all by itself. So I have to divide both sides by t squared. So next up, 2 times d divided by, put this in parentheses, t squared, because you want to make sure that only the t is squared, equals a. All right. Now, why did we do that? That actually tells us the equation we have to put into this column here to get our acceleration. So I'm going to write equals, right, 2 times d. Pick your d value here. There it is. Divided by, parentheses, t squared, close parentheses. Now, when you hit enter, there's going to be a problem. okay? Look at what we're doing. We are dividing by the time squared. Look at that time. That's a problem, right? If we divide by 0, so we're actually going to get that this is undefined. But it's only undefined at that first data point. So let's, like we did before, get the cross click, drag down, look at those acceleration values. Pretty consistent, and they should be. So let's get rid of that first data point. All right. So that looks pretty nice. So this is constant acceleration. All right, sorry about that. So then you can use this information to find the average acceleration. Just use the average function equals average. Just select your values. Close parentheses, enter. Look at that, we got our average acceleration. So this is another way to find the acceleration, okay? Is that the only, no, there's even another way to do this. So let's say you wanted to create an acceleration versus time graph. Control, insert, chart. Notice how it's pretty constant. So the acceleration is constant. Think about that. What should a constant graph look like? Okay, when we graph a constant, what does it look like? So how are we going to fit this? There's no perfect way to fit this, and I don't even know if this is the best way to do it, honestly. But we're going to fit it with a linear. Okay, maybe there's a better way, but we'll fit it with a linear trend. Ideally, it should be flat, but it's going down a little bit. Why is it going down? Maybe the acceleration is going down over time, like maybe there's some friction slowing it down or something like that. Because there's minimal friction there, but there's a little bit. And we're going to label it with an equation. The slope should be pretty close to 0. Look, it's less than 0.1. The y-intercept in this case, if this were a perfectly flat line, the y-intercept would be a really good indicator of the acceleration as well. Okay, so we just did this and found several different methods to find the acceleration. They're all correct. They all have their uncertainties, and we can talk about like which way might be the best. But overall, this is a really good practice in understanding the shapes of the graphs. What does displacement versus time, velocity versus time, and acceleration versus time look like for an accelerating object? And how do we use those graphs to find acceleration or velocity or whatever we need to find? All right. So hopefully this was a little bit helpful. Hopefully you won't have too many issues with this lab. But if you have any questions, of course, always feel free to ask. All right. Have a good one.